Got an operator drives the pedals at 20 RPM with an angular acceleration of 30 revs per minute squared. What I want to do is I want to find the angular velocity of the flywheel after 3 seconds. Okay. Now what we have here is a constant acceleration equation with an initial velocity. Okay. Before we get too far into this, what I think I'm going to do is I'm going to convert everything from revolutions per minute to radians per second. So we use the units that we're most comfortable with. So we'll start with the 20 revs per minute, 20 RPM. Okay. And then recognizing that I have 2 pi radians for every revolution. Okay. And then, oops, not equals. Not equal. That'll be times, again, 1 minute has 60 seconds in it. So again, minutes cancel, revolutions cancel, and I'm left with radians per second, which is going to be for this guy 2.09 radians per second. Okay, revolutions per minute squared, that'll be 30 rev per minute squared. So it's going to look very similar. It's going to be 2 pi, but instead of over 60, it'll be over 60 squared because I need to go from minutes squared to seconds squared. Okay, and from that I find that the acceleration, the angular acceleration, is 0.5 or 0.05236 radians per second squared. Okay, so again, now since it's the angular acceleration is constant, I can use constant acceleration equations. So again, what I'm looking for is I want to ultimately find, what am I looking for? The angular velocity of the flywheel. So I'll start by determining the angular velocity of omega A. And again, I'm going to do that knowing it has an initial velocity and then some constant acceleration, which I just calculated. Okay, so its initial velocity is 2.09. Its acceleration is 0.05236, and then this occurs at 3 seconds. Therefore, omega A equals 2.25 radians per second. Okay, now I've got a series of chains and belts that I'm going to treat just like I would treat gear ratios, again, because that chain has the same velocity anywhere along it, just like that belt does. So for example, I'm going to say that RA, which is what I know, omega A, okay, equals RD omega D. That should be a D, not a B. Okay, just like that. So from that, I can learn that omega D is the ratio RA over equals RA over RD times omega A. Okay, and again, do the same thing with B and E, where I would get RE omega E equals RB omega B. From that, I can find that omega E equals, oh, that should not be A, that should be E. Omega E equals RB over RE times omega B. And again, omega B and omega D are exactly the same thing. So I can take basically what I know about omega D and plug it in right there. So now plugging in the values for all of the radii, I can simply say, okay, omega F, which is the same as omega E, is just going to be 175 over 30 times 125 over 20 times 2.25, which is 82.1 radians per second. Again, just use constant acceleration equations to figure out the omega, then use gear ratios to find the omega of the value that I'm trying to find.